Hey guys, welcome back to eCoreAcademy's YouTube channel. I'm Tania and I'm back with the first lesson of a new course, Algebra 1. We're going to be discussing real numbers, if you couldn't already tell by the title. But before we get into those details, I'd really appreciate it if you guys liked this video, commented down below, subscribe to our channel, turn on the post notification bell, and share this platform with others who may benefit off of it. So now without further ado, let's just go ahead and get right on to the deets. So you may be questioning, what even are real numbers? Well, there are 5 types of real numbers, and the first 4 types that we'll be discussing kind of build onto each other, and you'll get what I'm trying to say as we progress through the video. But then the last type is it's basically any real number that's not these 4 types. Again, you'll get much more of an understanding of what I'm trying to say. We'll also discuss what non-real numbers are, and then we'll apply all of these descriptions and definitions that we have in the first 2 slides into actual problems when trying to classify whether or not they're real numbers, and if they are, what type. So let's start discussing the first type of real number on the list, which is natural numbers. Natural numbers are your counting numbers. So 1, 2, 3, 4, 5, 6, and so on. The way that I like to think about it is because there are counting numbers, and we always go 1, 2, 3, go, or something like that, they come naturally to us. They are so natural, like natural numbers are counting numbers. The second type of real numbers is whole numbers, and whole numbers are counting numbers with the inclusion of 0. So it would be 0, 1, 2, 3, 4, 5, 6, and so on. When I said earlier that these build off of each other, I meant to this is kind of what I'm trying to say, that whole numbers includes natural numbers. And so that's a pattern you'll see in the first 4 types. So for example, the next one is integers. Integers have to be whole numbers and can also be in the negative end of the spectrum. Meaning integers are whole numbers, so they're automatically natural numbers, but they also have the new addition of being on the negative end of the number line. So it can also be -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, and so on. They're just, integers also include negative whole numbers. Lastly, for this slide, there's rational numbers. Rational numbers include natural numbers, whole numbers, integers, and any number that can be written in the form x over y, where x and y are integers and y does not equal 0. If you may be wondering why y should not equal 0, you already know that when y is the denominator of a fraction, I mean that when the denominator of a fraction is 0, the number or that value of the fraction will be undefined. Therefore, it will be a non-real number, which is the opposite of real numbers, kind of against this whole point. So that's why when a number is written in the form x over y, y has to not equal 0. Additionally, for rational numbers, kind of giveaway would be to realize if it's a repeater, then it's a rational number. When I say repeater, I just mean 0.51 repeated, which is 0.515151515151, and so on, continuously until infinity and beyond. So some examples of rational numbers would be 3/4, 4/5, -1/2, 0.38, 0.79125, 172, -89, -0.11 repeated, 0.4 repeated. As you can see, rational numbers, the examples I've listed, kind of include natural numbers, whole numbers, integers, as well as the inclusion that rational numbers itself gives. So those are the first 4 types. Those are the types that build off of each other. But then there's a 5th type of real numbers. that does not build off of anything. It is basically all the other types of real numbers that is not included in a rational number. Though that type is known as the irrational number. Rational versus irrational. You get the gist. So irrational numbers are numbers that cannot be exactly expressed as a fraction, meaning it will not be able to be expressed as in the form of x over y. And also, they're non-perfect squares. This is also a really good giveaway, because a lot of people may miss this fact, but any non-perfect square value will be non-repeating and non-terminating. So that is why that is also what irrational numbers mean. So for example, our first, most common example of irrational numbers is pi. We know that there's a value of pi that's attached to the symbol, which is 3.1415925, and so on. We commonly just say 3.14 is equal to pi. But again, like I mentioned, it's a whole sequence of numbers that continues to go on and on, making the value of pi. But that being said, when I was saying those numbers in the value of pi, you should have noticed that I did not repeat any numbers. None of the numbers were repeating. And when I said and so on, I was indicating that it was non-terminating. To terminate means to end. So terminating means ending. So non-terminating means non-ending. They are continuous values. So pi is a great example for an irrational number, just like the square root of 54 is. The square root of 54, that is not a perfect square. So, for example, the square root of 36 is a perfect square. It equals 6. But the square root of 54 is not a perfect square. And because of that, because it's a non-perfect square, the value of the square root of 54 is actually a non-repeating and a non-terminating value. And that's with any square root of any number that is not a perfect square, that results in no perfect square. Another example would be negative square root of 117. So that was the fifth type of real numbers. Now on to the non-real numbers. Non-real numbers, another name for them is undefined number or imaginary number. Those three names are really just synonyms for each other. Imaginary number is what you will be using in Algebra 2. That's actually when you will work with imaginary numbers. You will do math with all that. For our sake in Algebra 1, we're not going to be going all that in depth because it's not an Algebra 1 subject, I'd say. So for our sakes, we're going to just call it an undefined number. So non-real numbers, if you remember from just a couple of minutes ago, I did say that if a fraction has a denominator of 0, that value will be undefined. Therefore, it will be a non-real number. Also, non-real numbers are basically just a negative number inside of a square root. So, for example, the square root of negative 36 is an undefined number. The square root of negative 47 is an undefined number. I want to go back to the square root of negative 36. That's undefined, but the square root of positive 36 is 6. So there's a difference. There's a positive and a negative. A negative can never be in a square root. So, and like I mentioned before, in Algebra 2, you will learn about imaginary numbers, numbers that involve the imaginary I. It's a variable that you will see so much in Algebra 2. So there's that. It's coming. All right. Do quickly want to just remind you the difference between rational and irrational. So basically, remember that irrational numbers and rational numbers can both repeat. However, if a number is it can be non-ending. A rational number and an irrational number can both be non-ending. However, if that non-ending number has a repeating pattern, it's a dead giveaway that that number is going to be a rational number. But if that non-ending number has no pattern, then it's an irrational number. With that being said, rational numbers can also end. So it can just be 0.38, like we mentioned in our examples. These are just some notes that you want to take and kind of have that differentiating factors between rational and irrational, because those are kind of some defining factors of each of them, and you'll see that in some examples that we're going to work with right now. All right, so what we're going to do is that we are going to start with using this chart. This chart is basically going to help us classify real numbers. I do want to say that this chart, we're not going to work with non-real numbers for this purpose. Every number I give you when working with this chart is going to be a real number. We just have to find out what type of real number it is. Like we learned today, there are 5 types. So we have to conclude which type of real number or which types of real number the number that I give you is. So using this chart, our first example is going to be 56 over 7. So this chart is kind of our thought process when deciding what type of number it is. So we're just going to follow this, the questions, the answers, the arrows. So here we know that our first question is, can it be evaluated any further? Yes, it can. It's a fraction, but we know that 56 over 7 is equal to 8. So yes, it can be evaluated any further. And when evaluated, it's just 8. Then we follow our arrow. And the next question is, does your number have a decimal? There is no decimal with this 8, so no. Follow the arrow. The next question is your number negative? I don't see a negative sign. It is positive, so no, it's not a negative. The next question is your number 0? It's 8. It's not 0, so no. And so now we know that our number that we're dealing with here is a natural number. Because it is a natural number, it is automatically a whole number. It is automatically an integer, which is automatically a rational number. But here is where we draw the line. Just because it's a rational number does not mean it's an irrational number. So that's kind of where we draw that line. But when I was telling you about that build-up factor that they have, that build-up, how these just kind of build up on each other, this is exactly what I meant. If it's a natural number, it's automatically a whole number. If it's a whole number, it's automatically an integer. If it's an integer, it's automatically a rational number. With that being said, if it's a natural number, it's literally all a whole number, integer, and a rational number. If it's a whole number, then it's an integer and a rational number. If it's an integer, then it's also a rational number. But a rational number is not a natural number. It is not a whole number. It is not an integer. Rational is it includes all, but doesn't really go to anything else. Irrational number is any real number that a rational number is not. That's kind of the way that I remember this. So now let's clear the screen and move on to our next number. So our next number that we're going to be dealing with is, the square root of 10. So that, yeah. Okay, so our number is the square root of 10. Can it be evaluated any further? Of course, we just need to use our calculator to get perhaps a decimal format. Okay, so with our calculator, you don't need a TI, so you can also use a basic Algebra 1 calculator. But when you plug it in, you will get the result of 3.1622766, and it goes on. But yeah. With that being said, does your number have a decimal? My number does have a decimal. Does that decimal end or have a repeating pattern? That decimal does not end, and it does not have a repeating pattern. Like I said earlier, it goes on, indicating that it is a non-terminating number, meaning this number is an irrational number over here. But before we I just want to point out that we didn't have to go through this whole map process. You know that in the beginning, the fact that it was the square root of a number that does not result in a perfect square is kind of a dead giveaway that it is an irrational number, because you know that all values of the square root of numbers that are not perfect squares result in non-terminating and non-repeating values. So there we go. Like I mentioned before, this chart here is just for a thought process in the beginning. This is you're never gonna see this again, really. Like by the time that you continue your practice with this and you make use of it in your lessons and everything, you will see that this chart you don't even need. It'll be second nature for you to identify whether a number is a rational number, an irrational number, a real number, or a non-real number. So now we have now we have our third example that we are going to work with in this chart. So all right, so the number that we're going to deal with for the third example is 61 point, please mind my handwriting, it's 87103 ... indicates that it's gonna continue on. It's a non-terminating number. Something that I would like to advise you to do is to kind of look for these dead giveaways from the very beginning. So for example, I'm gonna try to not, we're still gonna do this map direction thing, but we're gonna kind of note out some things that we notice. We know that this is a decimal number, meaning it kind of cuts off the first three types of real numbers. So it can only be a rational number or an irrational number. The fact that this is non-terminating, it can be both. But if we remember correctly, rational numbers are only non-terminating when there's a repeating pattern after the decimal. 0.87103 and on does not give me or show me any sort of repeating pattern, does not hint towards one. Therefore, I think it's safe to say that this is an irrational number, but let's follow the chart and see what it tells us. So first of all, can we evaluate this any further? Not really. This is already in decimal format, so it's a no. Does your number have a decimal? Yes. Does a decimal end or have a repeating pattern? Like mentioned before, it does not end and it does not have a repeating pattern. Therefore, it's a no, and so it is an irrational number. You know, it's quite simple. We just have to kind of look at it, study it very quickly when we first get it, and it's much more easier to identify then. So now with our last example using this chart, we are going to, okay, so the last number that we're going to use, or we're going to work with when using this mind map, will be 57.01313, repeat. All right, so we know our number is 57.0131313 repeating. Remember those dead giveaways? Repeating kind of indicates that it's already going to be non-terminating. It is a continuous number because that what's being repeated is going to be repeated again and again and again. It is a repeated number. I think it's safe to say that it is a rational number because it's non-terminating, but it's a repeater. But let's follow the chart. So can this be evaluated? No, because it's already in decimal format. Does your number have a decimal? Yes. Does that decimal end and have a repeating pattern? That decimal does not end, but it has a repeating pattern, which we know is a dead giveaway that it is a rational number. The wording of this is kind of iffy, but I think that using our definitions that were given beforehand will, before we use this mind map, which is never going to be with us always, is a much better use. So did want to point that out, but this mind map did get the point across that I was trying to share with you. It's a process, but it really becomes second nature the second that you get more comfortable with this, that you gain more practice with this. So now, now what we're going to do is that we're going to actually work with three or four examples without the use of this mind map. I don't want you guys to get used to this mind map. It was just for the beginning, but I really do not recommend for you to constantly depend on that. But these examples that we're going to be doing together are going to be the examples that we want to study more often. So let's see what we're working with. So the number that we're working with is 17.382965 ... So we know that it's a repeating number. It's a non-terminating number because the ... indicates that it continues. We know that there is no repeating pattern. Kind of already have an idea of what sort of number this is. But let's look at our question. Is it a real number or a non-real number? Well, I think that's also a dead giveaway. There is no show of undefined number. There is no fraction with 0 as a denominator, nor is there a square root of a negative number. I'm pretty sure it's safe to say that this is... Whoa. Excuse me. Sorry. Wrong side, but I'm pretty sure it's safe to say that this is a real number. Now, if the second part of the question asks if it is a real number, what type of real number is it? There are 5 types. We already know, like I said, I mentioned the dead giveaways, and I noticed the dead giveaways with you guys right when we saw that number. It is a continuous number. It's a non-terminating number, so it can be both repeating. It can be both rational or irrational, but we know that if it's a rational non-terminating number, it has a repeating pattern. 3, 8, 2, 9, 6, 5. I don't really see a repeating pattern. So since there is a non-repeating pattern and a non-terminating value, it's safe to say that this number is irrational. So I hope that you guys kind of are getting the hang of this. Those focusing on those like early like the second you see the number, just kind of pointing out some clues, some kind of obvious things, some dead giveaways, like I've been saying this whole video, is really helpful, making note of that. And we've already made notes of distinctions in our actual notes. So you can reference back to them for in this case, but like I said, with more practice, it's going to become second nature to you guys, and you guys won't have to worry about going through this whole process of thinking out loud, using that mind map. So, sorry. Anyway, let's continue. So our next number that we're dealing with is the square root of -36. The question is the same as the last. Is it a real number or a non-real number? Well, this, once again, is a dead giveaway. That negative inside of a square root is indicating that it's a non-real number. We don't even have to continue on or try. We don't have to try to read the next part of the question. So now the next question, that the next number we're dealing with is 63/49. So, see, I would, before when we were dealing with a fraction, in the mind map, it kind of asked, do you want to, do you want to evaluate further? Can it be evaluated further? Of course, this can be evaluated further. It can be divided by 7. I'm getting ahead of myself here. We know it's a real number for sure because there's no indication of it being a non-real number because there is no 0 in the denominator. It's a 49 for the denominator, and there is no negative in a square root. So since it is a real number, what type of real number is it? That's what I was kind of getting to, so my bad. I'm really sorry about that. Kind of got ahead of myself for a second there, but like I said, before, when we were dealing with the fraction, when we were working with the mind map problems, it asked us, can we evaluate this further? Well, we know that 63/49 is 9/7 because both numbers are divisible by 7. And yes, it can be evaluated further. And we can even go further than this by actually plugging it into our calculator and putting it in 9/7. But the thing is, why would you want to do all of that? When we remember, since we already know it's a real number, when we remember that we know it's not a natural number because it's not 1, 2, 3, 4, 5, 6, something like that. We know it's not a whole number because there's no 0, 1, 2, 3, 4, 5, 6. Same with integer. It's not a negative whole number, meaning it's a rational number or an irrational number. But if you remember, the difference between an irrational number and a rational number is the fact that a rational number could be expressed in the form x over y, where y does not equal 0, and x and y are both integers. X is equal to 63 in this case, and y is equal to 49. Both of them are integers. And if you remember correctly again, irrational numbers are unable to be expressed as fractions. So, with all of that being said, with making use of the information that we've had from our previous notes and kind of those dead giveaways that we've been having, following the mind map if needed, we already know that this number is a rational number. And that right there is the answer to what type of real number it is. It's a rational number. So, clean this out again. So I just wanted to make quick note of saying that, like I mentioned before, you do not have to go through this whole long process of thinking this out to yourself, having to evaluate if unnecessary. It was unnecessary to evaluate this. It could have been evaluated further, but there was no need to. I did want to start you off with that because it would have been easier for you, but as we progress through this, if it's not necessary, you don't want to waste your time doing it. So, with that being said, I think that we are going to do one more problem. Excuse me. And this problem, the number that we're dealing with is 58 pi. I want you to take 1 second to yourself and just name a dead giveaway out loud. 1 Mississippi. Okay, that was 1 second. The dead giveaway should have been that pi. But with the question, is it a real number or is it a non-real number? Well, we know that it is a real number because there's no indication of a non-real number. I don't see a fraction with the denominator being a 0, nor do I see a square root of a negative number. But if it is a real number, what type of real number is it? We discussed before that pi, anything that involves pi, is going to be an irrational number. Why is that? Because pi has this value of 3.14159265, and so on. The value of pi is non-repeating and non-terminating. That's the definition of an irrational number. So 58 pi, that 58 is still with the pi. Therefore, together they're still going to be a non-terminating and a non-repeating pattern. So I think it's safe to say that this one is the type of real number it is an irrational number. There was no competition with it this time. Well, that was it for this video. It wasn't too much. It was a lot of, different aspects to look at, but I hope you guys understood. I hope you guys had fun learning our first lesson together. If you guys have any questions, please do not hesitate to leave them down below. Any comments, questions, concerns, all down in the comment section below, and we'll get back to you as soon as we can. But with that being said, don't forget to like and subscribe to our channel. We have the website link if you guys want to get more practice for real numbers, which will be on our website, as well as if you have any, if you want to contact us in another way, we have our Gmail account right here. And also you can follow our social medias. We have Facebook, Instagram, and Twitter. Follow our handles there. And that is it for this video. I hope you guys enjoyed this. Cannot wait to see you guys next time. And it's a new lesson next time. So, yes, have a great day, y'all. Bye.